last video, we defined a derivative using this formula. F prime of x0, which is our notation for derivative, is the limit as h approaches 0 of f of x0 plus h minus f of x0 all over h. And this thing right here is called the difference quotient. So this is how we defined the derivative. And now we'll do some examples to look at showing exactly how this works. Our first example is the function f of x equal to 5 for any value of x0. So we want to find our derivative. We have the limit as x approaches x0, as the limit as h approaches 0. And then we have f of x0 plus h. Our function is 5 regardless of what x is, so on the top we just have a 5 minus f of x0, which is 5, all over h. This is now 0 over h, or the limit as h approaches 0. Of 0 over h. And 0 over h is just 0. So our limit is 0. And this is going to be true of any constant function. If f of x is equal to constant, any constant, then the derivative is going to be equal to 0. Now let's do a slightly more complicated example. I want to find f of x0 equal to x squared. I want to find the derivative at 2. So we have the limit as h approaches 0 of f of 2 plus h. So I have 2 plus h squared minus f of x0 squared, so 2 squared, all over h. And now we can simplify. When I square out the top, I get 4 plus 4h plus h squared minus 4 over h. We can see that those 4's cancel on the top. I'm left with 4h plus h squared over h. I know I can factor out the h on the top. Now I have a 4 plus h over h. I can now cancel 2 of these h's. So now I just have the limit as h approaches 0 of 4 plus h, which is 4. So I do have my limit. And now I have the value of my derivative. The derivative of x squared at 2 is going to be 4. So now that we've done a couple of small examples, let's talk about exactly what the derivative is. The derivative is the slope of our tangent line. And the tangent line just tells us if we have a graph, it's the line that cuts through the graph at exactly that one point and none of the surrounding points. So we know that the derivative is the slope, and we know that this line passes through the point that we have of interest, x0, f of x0. So I can find the equation of the tangent line. In particular, it's going to be y equal to f of x0 plus f prime of x0 times x minus x0. So now that we've done that, let's do a few more examples, both of finding the derivative and of finding this tangent line. Let's start with an easier one, f of x equal to x squared at x equal to 2. So we know if x is 2, then 2 squared is 4. And we also already found the derivative of x squared at 2, which was 4. So my line is f of x0 plus f prime of x0 times x minus x0. So we have this 4 plus this 4 times x minus 2. So my tangent line is 4x minus 4. Let's do another one. F of x equals to x squared, but this time we're going to find the tangent line at x equal to 1. So I know if x is 1, then f of x is also 1, since 1 squared is 1. But I also need to find the derivative, and this time I don't already know it. So I'm going to take the limit as h goes to 0 of f of x plus h, so 1 plus h squared, minus 1 squared, all over h. So as the limit as h approaches 0, once we multiply this out, I have 1 plus 2h plus h squared minus 1 over h. Simplifying, I'm going to cancel this 1 and negative 1 and go ahead and factor out an h from the top. I'm left with 2 plus h over h. And now these h's will cancel, and the limit as h approaches 0 is 2. So now my line is f of x 0, which is 1, plus the derivative, which is 2, times x minus x, which is 1. So this time I have 2x plus 1, or rather minus 1, as the equation of my tangent line. Let's look at one more example. This time I'm going to do x cubed at x equal to 1. So I know that x cubed is 1, but this time let's think about what our derivative is. We need x plus h, so 1 plus h. This time we're cubing, minus 1 cubed, all over h. We can expand that out. It would give us 1 plus 3h squared plus h cubed minus 1 over h. Once again, our 1 minus 1 cancels, and I can factor out an h from the top. I'm left with 3 plus 3h plus h squared over h. And when I cancel and try to take the limit as h approaches 0, I get 3. So this time my line says f of x 0, which is 1, plus my derivative, which is 3, times x minus x 0, which is 1. So this time I have 3x minus 2. So we were able to figure these out by taking the derivative, but finding the derivative, as we can see, can be very time consuming. These things take a lot of work. So now in the next few videos, we're going to try to establish some shortcuts for taking the derivatives so we don't have to use this complex formula every single time.